Hey guys, hello and welcome to another video of this YouTube channel Elementary Physics, and today in this video I'm going to be talking about Miller Indices, which is a very important topic in solid state physics. So Miller Indices is basically used to find the planes that are densely packed with atoms for any kind of solids. Okay, by using diffractometer we measure the scattering angles from the planes, and by using this we can easily find the structure of any kind of solid, whether it's BCC, FCC or simple cubic. So let's get into our index. So here it's our index. I just break that index into three parts: introduction, Miller indices, and some example. In introduction, I'm going to tell you about some preliminary topics that is required to know before we can find the Miller indices. In Miller indices part, I'm going to tell you about how you can find the Miller indices of any kind of planes, and here are some examples. These are Miller indices of the planes, and I'm going to show you which plane suggests these Miller indices. So let's not talk more, let's get started. So it's our introduction. So in crystal lattice, there are sets of planes which have larger concentration of atoms or group of atoms at the lattice sides. The orientation of such parallel planes are usually expressed in terms of three numbers that usually called the Miller indices. Okay, so first we have to know about what is a unit cell. So here it's unit cell. To understand the meaning of the Miller indices, we first consider two-dimensional lattice as shown in the figure, right? Okay, so it is a two-dimensional lattice. Okay, so I just take O as the origin. Let's name these quadrilateral as OABC. As you can see, it's the simplest structure possible here. And now let's take, this is the x-axis, and this line here, it suggests the y-axis. So the distance between two adjacent atoms along x-axis is A and y-axis is B. Okay, the green dot suggests the atoms. The green dot suggests the atoms, and the black line suggests the array of the atoms. And by repeated translation of the unit cell, we can create the whole structure of the solid. So now let's take an example in 3 dimension. So here it's a simple cubic structure. The red arrow suggests the z, x and y axis. The green dot suggests the atoms, and the distance between the atoms along z axis is c, along y axis it's b, and along x axis it's a. So this is the simplest structure you can assume of a 3-dimensional unit cell. It's basically called a simple cubic. There are many kind of structures possible. That's not the topic for today. I'm going to tell you about in another video. So let's get into the next page. How you can find the Miller indices. Okay, for finding the Miller indices, let's take again the 2D array with two different translation vectors A and B. Okay, now again we take the same 2D array, just name them as OABC. Now here I show you that this is a x-axis and this is y-axis. So the distance between two adjacent atoms along x-axis is A, and along y-axis it's B. So now let's draw a line MN. So here I'm going to take a line, and then I'm going to tell you how you can find the Miller indices of the line for a 2-dimensional array, of course. So this is our line MN. Let's name this as M and N. Now as you can see that along x-axis the line MN cuts at a point N, which is the position of another atom, but the distance between from the origin of that atom is A plus A plus A, which is 3A. So the line MN cuts the x-axis at a distance 3A unit. So, and again, if you take the line, the point M, the line MN cuts the y-axis at a point M, which is a distance of 2B from the origin, as OC is the translation vector along y-axis, it's B, and again CM it's B. So the distance that MN cut at the y-axis it's 2B. Now if we are take A and B as a unit, so in the unit of A and B, I can easily get 3 and 2, and by taking the ratio of their reciprocal 1 by 3 is to 1 by 2, we get 2 is to 3. Here I just multiplied 2 with both the numerator and the denominator for the first case, and 3 with both the numerator and the denominator for the second case, and the denominator of both sides cancel out so that we get 2 is to 3. Now that is the Miller indices of a two-dimensional array. So if we are going to find the Miller indices for a three-dimensional array, so we'll get a plane. Okay, so now if we consider 3D array of these unit cells having A, B, C as translation units along 3 different axes, if a plane cut these 3 axes, we get 3 different cut points along 3 axes, and then we go to reciprocal it, and then by taking the ratio of them, we easily get the Miller indices of a plane. So now as we now understand how we can find the Miller indices of any kind of plane, let's get into some examples. So here are some examples. First, now here I am going to tell you what are the Miller indices of a plane, and then we are going to find which plane suggests those Miller indices. So first case, let's take the Miller indices is 1, 0, 0. So here I'm taking a three-dimensional coordinate system, and let's name the origin as O. Unit distance along x-axis is A, distance along y-axis is B, and the unit distance along z-axis is C. So here it is the plane. Now as you can see, the plane cuts the x-axis at a point A. It doesn't cut y or z-axis. So the plane has a cut point at A and don't have any cut points along the y or z axis. So I can take it as the plane is parallel to y and z axis, or I can say that the plane will cut the y or z axis at the infinity. Okay, so the cut points are A, infinity, infinity. Just reciprocal those cut points, and taking the ratio of them, we'll get 1 by A is to 0 is to 0, and now in the unit of A for x-axis we get 1, 0, 0. Okay, so this plane suggests the Miller indices 1, 0, 0. Now we are going to take another. So now what does this plane suggest? This plane. Okay, so as you can see here, the plane cuts x-axis at a point A, y-axis at a point B, but doesn't have any cut with the z-axis. So the cut points are A, B, and infinity. As it is parallel to z-axis, so we take it as the plane will cut the z-axis to the infinity. So the cut points are A, B, and infinity. Now we are going to just reciprocal them, and taking the ratio of them, we get 1 by A is to 1 by B is to 0, and now in the unit of A and B, we'll get 1, 1, and 0. So this is the Miller indices of the plane. Now another example, 1, 1, 1. Okay, so again we take a plane. Now as you can see, the plane has cuts with all those 3 axes. It cuts the x-axis at a point A, y-axis at a point B, and z-axis at a point C. So it is very easy. Now just take the reciprocal of them. 1 by A is to 1 by B is to 1 by C, and in the unit of A, B, and C, we get 1 is to 1 is to 1, which is the Miller indices of the plane. Another example, 1, 1 bar, 0. As you can see, here the plane has a cut x-axis, but it doesn't cut the positive y-axis. It has a cut with a negative y-axis. So it cuts the y-axis at minus B and don't have any cut with the z-axis. So we can take the cuts are A, minus B, or infinity, and just by reciprocal them and taking the ratio of them, we will get 1 by A is to minus 1 by B is to 0, and in the unit of A, B, and C, we get 1, 1 bar, 0. Here we refer the negative cuts as 1 bar. So the Miller indices of this plane, which has a cut with the negative y-axis, is 1, 1 bar, and 0. Now let's get into our next example. 1 bar, 1 bar, and 0. So as the plane has a cut with both the x and y axis, but in a negative direction. So the plane has a cut with the x-axis in a minus a at minus a, and has a cut with the negative y-axis in at minus b, and doesn't have any cut with the z-axis. So the Miller indices will be 1 by minus a is to 1 by minus b is to 1 by 0. That means in a unit of a, b and c, and by referring the negative terms as 1 bar, we get 1 bar, 1 bar and 0. And this is the final example. So here the plane has cuts with all the axes but in all the negative directions. So the plane has cuts with the x-axis at minus a, y-axis at minus b, and the z-axis at minus c. So the Miller indices will be 1 by minus a is to 1 by minus b is to 1 by minus c, and this suggests the Miller indices will be 1 bar, 1 bar and 1 bar. So that's all for today. Hope you enjoyed my video, and forget not to subscribe my channel. Click the bell icon so when I made a new video you will have a notification from YouTube. So that's all for today. Thank you for watching.